Today we're going to talk about 1872 90-degree triangle. And the questions that could be asked are quite different. For example, we can say we know one of those three sides, which here we call x, y, and z, and we can ask to find the other sides. Or we can give one side and ask the area of this triangle. Now, one way to solve this problem is to use trigonometry. You can say, hey, we know what sines and cosines of 18 and 72 degrees are, and just use that knowledge to find other sides from one side. And I left a link to a video where trigonometry of 1872 degrees is discussed. You can go there and see how it's done, how to calculate sines and cosines of those angles, just using pure trigonometry. But here we would like to use geometry. And let's see how can we solve these problems using geometry. So what we're going to do here is we're going to take this triangle and reflect it over the side BC. In this case, we're going to get the triangle ADC. And one thing to note is that for this triangle ADC, the angle A will be 72 degrees and angle C will be 36 degrees. And what's interesting about this triangle is that one of the sides of this triangle is half the measure of the other side. And I left the link to a video in the description to this video where I discuss more general ideas about the triangles with two angles where one of the angle is half of another angle. So, but here we're going to use that type of constructions. It's very useful here. So what we're going to do, we're going to take the side AD here and make another side of this length to create an isosceles triangle ADE. Angles at the base of isosceles triangles are congruent, therefore this angle E here should be also 72 degrees. But now if we look at this angle here, this angle is an external angle to triangle EDC. And that means that this angle 72 degrees equals to the sum of this angle 36 degrees and angle right here, angle EDC. So this angle EDC should be also 36 degrees. And now in triangle EDC, we got two angles of 36 degrees. So this is an isosceles triangle, and that means that DE should be the same length as EC. The next thing we're going to do is we're going to look at triangle ADE. We see two angles there of 72 degrees. It means that the third angle right here should be 36 degrees. But that means that DE here splits the angle D, big angle D, ADC, into two congruent angles. So DE is an angle bisector. And when you see angle bisectors, you should immediately think about angle bisector theorem. It's a very useful thing to know. Just to remind you, when I have a triangle with two sides A and B, and I'm gonna draw this blue angle bisector that splits the top angle into two congruent parts. And this angle bisector splits the third side of this triangle into segments C and D. In this case, the ratio of A to C should be the same as the ratio B to D. And now let's apply this knowledge to our triangle. We find that AD over AE should be equal to CD over CE. And now just to remind ourselves that AD and CE should be equal to 2x, they're congruent. CD is Z, we call it Z, and AE is AC minus CE. And now what we do, we substitute these values into the formula for angle bisector theorem. This is what we're going to get. The next thing what we want to do, we really want to find the solution not for x, not for z, but for the ratio x over z. So we're going to divide numerators and denominators for both left-hand side and right-hand side by z. That's what we're going to get. The next thing is to multiply both parts of this equation by denominators, by this and by this. And when we do, we're going to get a quadratic equation with respect to x over z. And just to remind you, if I have a quadratic equation like this, at squared plus bt plus c, this equation has two solutions for t. That could be written like this. One solution with a plus sign, the other solution with a minus sign. In our case, t is actually x over z, a is 4, b is 2, and c is minus 1. So we're going to get that x over z should have two solutions like this. But the next thing we need to remember that we're not really solving this equation just to solve this equation. We really want to find the ratio of two sides, x and z. Sides are positive values, so x over z has to be positive. And that leaves actually one of those answers for us. And that's the solution with a plus sign here in front of square root of 5. So that's all we need to know from this drawing. So let's go back to our original triangle. Now we know the ratio of x to z. Now if we want to find the ratio of y to z, that's easy to do. We know Pythagorean theorem that relates the z, x, and y. We divide both sides of this equation by z squared, rearrange the terms, and we can find y over z as this expression. And really, that's pretty much all we need to know. So if you know any of the sides here, you can use these two formulas to find the other two sides. And from that, you can find the area of this triangle by multiplying x by y and dividing by 2. And you know. Now let's go back to trigonometry. That's where we kind of started. So we can clearly see that for angle of 18 degrees, x is the opposite leg and z is the hypotenuse. So x over z will be sine of angle of 18 degrees. Now for angle of 72 degrees, x is actually adjacent leg. So x over z will be cosine of 72 degrees. For y over z, sine and cosine here switch places because y is the adjacent leg for the angle of 18 degrees and it's an opposite leg for the angle of 72 degrees. So this is cosine of 18 degrees and sine of 72 degrees. So now what you can do is to actually go to the link to the video I left in the description here and watch how to obtain sines and cosines of these angles from purely trigonometric perspective and see which one you like better. The other thing you can do is to look at the cosine of 18 degrees. What you find here on the top is nested square roots. What I mean by that is you have square root of 5 inside of another square root. And we know that sometimes we can simplify this and basically get rid of one of those square roots. And I left a link to a video where I describe the procedure, how you should do it. And what you can do, you can try to do it for this example and see what's going to happen. And just leave a comment what you got.